Okay, so the last topic we're going to cover this week is arc length. So the length of an arc is a portion of the circumference. So remember, the circumference was the distance around the circle. And so when we talk about arc length, we're just calculating just a tiny portion of it. So again, that formula is L equals X times C over 360. So X is that degree measure of the arc, which we just talked about how we find. So it's that central angle. If this is X degrees, that means that the degree measure of the arc is the same. Times C, which is our circumference. Remember, that's either C equals 2 pi times R, or C equals the diameter times pi. And then we just divide it by 360. Okay, all we have to do is write in the numbers into our formulas and then put it in your calculator. So these are relatively easy problems. So the first example, we want to find the length of the bolded arc. All right, so if this is 100 and the central angle right here is 107 degrees, that means here X equals 107 degrees. All right, our radius is 6. So that means our circumference is 2 times pi times 6. All right, so we're going to put this information into our formula now. So our arc length is 107 times 2 times pi times 6. And that is all over 360. Now, we want to simplify this. So this is how we show our work on these problems. So calculate 107 times 12, and that's going to give you 1,284 pi divided by 360. I do expect to see this step. It's really important that you write everything out, because if you accidentally calculate it wrong in your calculator, I can still see that you understood what you're supposed to do. All right, and then this will give us 11.21. Our unit of measurement is meters. Do not forget your unit of measurement. And I know it says rounded to the nearest tenth, and I did not. So it should be 11.2. Sorry. All right, let's look at the next example. So here we're given this central angle, which means in order to find X, we have to do 360 minus 142. So this means that X is 218. We have a radius of 4. So that means our circumference is, let's just multiply that by 2. It is 8 pi, because it is the diameter times pi. All right, let's put in our formula. So L equals 218 times 8 pi. And that's all over 360. All right, so we multiplied 218 by 8, and we get 1,744 pi divided by 360. Into our calculator, we put that, and we get 15.22, and our unit of measurement is centimeters. Okay, let's look at our next example. So we are told that VS, so a diameter, is 12 meters. That means our radius is 6 meters. All right, you want to find the length of UT. So we've got some information that will help us find that. First, we can see that these two angles together make 180 degrees. And so we really can see, if we wanted to, we could find this is 53 degrees. That means that this is 53 degrees. And that means that UT is going to be, this is 90 degrees. If we wanted to, we could just do 360 minus all of these, minus 180 minus 53. Or we can see that all three of these will add up to be 180. which means that it's just 180 minus 90 minus 53. Any way that you do it, we should be able to find that UT is 37 degrees. So that means that x equals 37. And now we put it into our formula. So the arc length of UT is 37 times, let's go ahead with our circumference. Our circumference is just going to be 12 pi because it's 2 times the radius pi. I wrote 2, but it's 12 pi. And that's all over 360. So we calculate 37 times 12. That gives us 444 pi over 360. And that's about 3.9 on our unit of measurement is meters. All right, let's look at the next one. So we have 90 degrees here. We have 47, we have 80. That means that this piece will be 360 minus 80 minus 47 minus 90, which is 233 degrees. Oh, sorry. We want to find FED. So it is, sorry, 43 degrees, or 100, oh gosh, 143 degrees. Okay. So FED, this whole thing is 90 plus 143, which is 233. So we have X is 233 degrees. Our radius, we're told FG is 27, so our radius is 27. All right, let's put this in our formula. So we have L. Oh, that means that our circumference is 54 pi. So L equals 233 times 54 pi divided by 360. So that means the arc length equals 12,582 pi divided by 360. And that means the answer is 109.8, and our unit of measurement is yards. All right, let's look at how we apply this arc length. So we have this application problem. So a car enters a roundabout from Mason Avenue, traveled 280 feet, then turned onto Perry Street. If the roundabout has a diameter of 150 feet, find the angle of rotation to the nearest degree the car traveled. So let's look at our arc length formula. So this arc length is the distance outside that circle. So if we have a car traveling along a circle, then it's 280 feet. We were already given the arc length. So for this problem, we know L equals 280 feet. Then it tells us that the roundabout has a diameter of 150 feet. That means that it's giving us the circumference. So it has a diameter, this circle, of 150 feet. So our circumference is 150 pi. And then it wants us to find the angle of rotation. So it's wanting us to find this angle of rotation that the car went into this roundabout. So that means that we're trying to find X. So let's put all our information in and let's solve for X. So our arc length, which is 280, equals X, which we're trying to find, times our circumference, divided by 360. So let's solve for X. First, we're going to multiply both sides by 360. So we get 100,800 is equal to X times 150 pi. And now let's just go ahead and divide both sides by 150 pi. So into our calculator, We enter that value and we get x equals 214 degrees. So my picture is not accurate, but we went 214 degrees. And that's arc length.